So what we need to do is we need to identify the problems in our data set, and then we need to treat them. Problems can be of different levels. We will look into missing values. We will look into the values that are supposed to be correct, but they are not. Okay. And all kind of inconsistencies that we're going to see in the data set we are going to discuss today. Again, whenever we are going to work on some kind of project, we implement machine learning or deep learning at the end of the project. 60 to 80% of the project basically revolve around cleaning the data set and making sure that everything is reliable and we have a quality data set that we can use to produce our results for machine learning. No, for that particular reason, we are creating a simple dummy data set first, and then we will clean it. After doing that, we will go to the real world data set and we will perform the similar tasks to identify and clean the problems in the data. Now, in the same manner, we first need to import our packages, and if we have the packages, we are good to go. Okay. Now, whenever so we already discussed that whenever we have big brackets, we are talking about data, and when we have small brackets, we are talking about functions, right? Whenever we have curly brackets, we are basically talking about dictionaries. Like in dictionaries, we have two types of data set. We first define the index, and then we define the data in the index. Okay. Now, dictionaries are basically a data type in Python that can store different types of data sets. Like here, we are able to store numbers, we are able to add characters in it, and all kind of data set. Now, why we are doing this? We are just trying to create a data set that we can use for our results. Do you have any question? No. Okay. So in that particular data set, we have 6 different columns. The first one is ID, and it contains numbers. The second one is names. We have multiple names. Third one is age, gender, salary, and department. Okay. And we added few data in it, and with some problems, like in that case, we have one here, and we are also getting a one at the end. We need to treat that, right? In the names, we don't have a name for some person. Instead of that, we have a question mark. So before jumping into that, the data, we need to understand that how data sets are how people are collecting data sets during surveys, so we can identify the problems, right? Now, whenever the government or some private organizations collects a data set, they use different softwares. Some people use Stata, some people use SPSS, some people use their own custom softwares to calculate the data set. So a person go with the tablet and they collect the data, or they are using some kind of online mediums that is collecting the data set. Now, in different types of data collection methods, different types of data is going to be generated. Like for example, if we are generating data set with SPSS, a software that is used to conduct surveys where people collect data set, right? Whenever they have missing values, it stores with a very big value, like something like 999 or something like minus 999, to make a difference that this particular value we don't know about that and it's a missing value, right? And in some particular softwares we get question marks that we don't know about that. Okay, and if we are in Excel, we are good to go. We will get a value something like that, where we have two different commas and there should be nothing. This particular thing, Python can identify that it's a missing value. But this thing, a question mark, or this thing, Python is going to treat them as it is, and we first need to tell the Python that this is actually a missing value and we need to remove it or we need to treat it. Okay. Now, this is a problem with missing values. Now, let's talk about a few other problems. Like in gender, we have a male, female, again a female, but with a capital F. We also have F and M. No, all these are supposed to be only two categories, male and female. But due to poor data collection, we are getting different kind of things that we need to treat, and we need to make sure that there should be only two, one male and other one female. This is kind of problem that we actually deal in data cleaning. We have different kinds of missing values, we have different kinds of numbers. Like this, we have salaries from 50,000, 60,000, 80,000, 55,000. All these make sense, but that actually quite a bigger number, and that doesn't make any sense. So in data sense, we call it outlier. That is basically in the data format, proper data format, but it's either quite a very big number or a very small number that doesn't make any sense in the scenario. So we call it outliers. Okay. So today we are going to treat the all kinds of inconsistencies, the missing values, how we can differentiate between a lot of categories and make them small, how we can identify outliers, how we can treat them, and all kind of stuff. Now this is a dictionary. Okay. And whenever we need to use a dictionary as a data set, we need to first convert it into a data frame, right? And for converting it into a data frame, we use pd.dataFrame. Data frame is basically a function in the pandas package that converts the dictionary into a proper data set. Now we did this, and we can just run df, and we will be able to see our whole data set. Now let's explore the data set. We already understand that we can see the number of rows, number of columns by df.shape. We already know we can see the different data types with G types, right? We studied that yesterday. When we run
Yes.
that, we are getting data shape, we are getting data types. In data types, we will see the problems, okay? So whenever, no, in that particular case, we are using only 8 rows, but when we have a big data frame, we cannot see every mistake by just looking at the data set. So we need to find the patterns to analyze that there is some kind of problem. To do so, we will use data types, okay? And if we look at the data type, from here we can identify there are some kind of problem. Like if we look at age, it is object instead of float or integer. It should be a number. Age cannot be an object. Object basically means it contains characters instead of numbers. Okay. And why we are getting object here? Because in age we have is question mark, and due to that particular question mark, it is considering all the numbers also as a character. Okay. As a character means 25 is just 25 is a number, but if we write 25 as a character, it lost its numeric significance, right? For example, let me open sticky notes for that purpose. Now we have a 25 and we add 5 into it and it becomes 30, right? Why? Because this is numeric. This has a numerical significance and we can use addition on that. But if our Python
Yes.
track is not considering it as a number, it will consider it as a character. Okay. And when we write 25 plus 5, no, sorry, it should be plus. Instead of 30, it will just collect them together. Okay. And it will show us something like 255. Why? Because
Yes. Yes.
it doesn't understand that it's just a number, it's not a character. Okay. So that's the kind of problem we are facing here. Instead of getting a number, we are getting object. Now we need to read that,
Yes.
and we need to also explore all kinds of problems. Now here we use direct question mark. Let me use something else from here. We are talking about, for example, names. And here we can use a function unique. Okay, so it will show us all the unique names in the data frame. Let me see what the problem is. Okay, so instead of unique, we can use value count. Okay, so it basically gives us that how many different names we have in our data frame. Okay, and from here we can see that we are getting a question mark, and we need to treat that. Okay. And now problem, we don't have any problem with the question mark. We have names here, and names it doesn't add any value to analysis. So most of the time when we are working in real world scenario, we will just remove the name column because names doesn't make any difference in any kind of analysis.
Okay.
Because when we are talking about data set with 10,000 plus rows, we have a lot of names and they cannot add any kind of significance, and we will remove them, the whole column. Here we are going to treat that as any other column, because we are trying to demonstrate that how we can solve that kind of problem if we face. Now, we understand that we are getting something like question marks, and we need to treat that. Also, from here, we can also use df.describe. No, df.describe shows all the numeric columns, but here it is not showing the age, and we know something is wrong with the age as well. Okay. In the same manner, like we use name, we can also use age here to see what kind of ages we got here. Okay. Now, the main problem that it is not numeric is due to this question mark. We need to remove it first, and then we need to make sure that age is a numeric column. Like if it's loaded as an object, we need to convert it. Even if we remove this one, it will still be a object instead of numeric column. So we need to make sure that it is in the numeric format. Now we now know that we have some kind of question marks in different columns, and we need to make sure that they are treated. Okay, what we can do is we can take a sum to identify that how many question marks we have in each column. Now, if we run that, we will see that names column, we have 1. In age column, we have 1. In gender, we have 1 question mark. Okay. And for the age, we are using -999 because we have a problem, something like that. Okay. And if we want to see that, let me explain that code a bit. We are using our data frame, and we are specifying that we are talking about the name column. Okay. And we are giving it a condition that where it is equal to question mark. Okay. Now, if we run this particular thing, it will show us that there is a 1 value in it. There is a 1 value that basically is question mark, and it's an integer type. In the same manner, we can see all kinds of different data types, that what kind of problem they are facing, and how many question marks are in there, how many -999 numbers are in there. Also, we can use unique function here, and with the unique function, we can also identify that what kind of unique data we have in it, and we can just see that we are facing some kind of problem here for different columns. So now we want to replace the missing values, we want to replace the question marks. Now we are going to replace the question marks with the actual missing values that Python understands. Okay. When we have something like question mark in here in our data, like in each column, it's a numeric column, but we have a question mark. Due to question mark, the complete age column is not considered as numbers. Instead, it's considered as characters, and it doesn't have any numeric significance. So we cannot do any kind of numeric operations like addition, subtraction, division, or anything like that. Okay, so we first need to remove them, and once we remove them, after that we can convert it into numeric form, and we can also impute the missing values however we want. Now here, what we are going to do, we are going to use a dot replace function. Dot replace function basically works on a data frame. If we are talking about the df clean, we can just use a dot replace function on that, and based on the dot replace function, we can give the previous value and we can give the new value. Now, previous value is question marks. Now, here we are using the complete data set, not just one single column. So it will go and treat all the question marks in our complete data set, and it will remove them and it will replace them with np.nan, basically the missing values, the actual missing values that Python can understand. And we are also replacing the -999 with the missing values as well, because they're actually missing values, but some softwares represent them as a -999. We are also going to implement the same function, the totally same function, Same thing, but instead of just question mark, we are using minus 999. Based on that, we can understand that whenever we have to replace something in our data set, we can replace it like that. Like for example, instead of zero, someone conducted a survey, and instead of zero, they are using O whole time, and that is causing the problem with the numbers. Now we know the solution, that we can just create with simple one line of code. We can replace the O with a zero as well. Now, if we want to replace it with some kind of number, we can just, instead of using that, we will just use a zero here and we'll replace it with the zero. Okay. So basically, this is the placeholder for the new value. We can write anything here, and we can also write anything here. So whatever will be here will be replaced with whatever we gave it. Now, once we run these lines of code, it will create a fresh copy. Based on that fresh copy, it will replace everywhere we have a question mark with the missing value, and where we have minus 999 with the missing values as well. After removing them, what we are going to do is we are going to see that how many missing values do we have. Now, in the first session, we used a function is null. So is null basically tells us about the missing values in our data frame in column if we want to see. Now here we are using the complete data, and we are using is null with paired with the dot sum. So it will calculate the sum of all the missing values in each column. Like in ID, we don't have a missing value. In name, we got one missing value. In age, we got two missing values. Gender, salary got one missing value. Now, the first problem that we have with the data set is rated. The problem was simple, like we just removed the question marks and minus 999 from our data set. Now, if we are going to see our data set, it will look something like that. Now here we have NaN, NaN, NaN. So basically all those values where we have some kind of different numbers, now we are getting a clean NaN. Now we have a missing value in the name column. Let's start with the first column name. And we are going to read the NaN here. It's going to be simple. We just write df dot name column, df dot name. And here we are using fill NA. So fill NA is basically a function where we can just tell it that if there is an NA value, you should use this particular value instead of the NA. Okay. And since it's a name column and we don't know the actual name, so we cannot just impute them. We can just write something like unknown. And this is exactly what we are going to do here. So here we are now seeing unknown instead of previous missing value. In each column, we already treated missing value problem, like question marks problem, but they are still in not in the numeric form. So we need to convert them into the numeric form. To convert a string to a numeric form, we have a function to numeric in pandas package. So whenever we're going to use this function, we need to specify that it's from pandas pd dot to numeric. Okay. And if you haven't run the first code, first chunk, it will not run. So basically, whenever we're working in Python, we make sure that we are running all the chunks in the right order. Like if we didn't run that line of these lines of code, pandas will not be imported, and based on that, these codes will not work. Okay. And now what we are going to say is from df clean, we are talking about the age, and we are replacing it with the numeric form of the same column, and we are saying that it if it encounter any kind of error, it will just remove that value. I'm explaining that. Okay. Basically, it's a format where we drop the value if we see any error. Okay. Like if we have some kind of error, it will just remove it. Like if there is some kind of number that it is unable to understand due to some kind of problem, it will just remove it. Okay. If we are converting some column from string to numeric, and there is some kind of string, like we have a number like 48.2, and all of a sudden there is something like a, b, or c, this problem, to avoid this problem, we will just use coherence. So it will just remove that particular number and convert it into a missing value. Now let's move forward. Now, till there, we just converted it into numeric column. But still we have the missing values in our age column, this one, and we have to impute it as well. Now, one of the best way to impute in the missing value is we can just add a mean or median value in it. Okay. So basically we take the average of whole data and add it on the missing values. Got it?
Yes.
Okay, now to do so, what we need to do is we need to calculate the mean first or average first. And if we want to calculate the average of age, what we are going to do is we are going to take our data and the same column age that we are talking about, and we just implement dot mean function on it. And it will calculate the age, mean of age, and save it in average age. And also, if we want to use median instead of mean, we can also use in the same manner. Okay. So instead
Okay.
of mean, we will just write median here. Once we saved it in our name average age, we can use it with the fill NA. Like here in the name, we filled it with the unknowns, and now we want to impute the age column with the mean value. So we calculated the mean age, and then we use exactly the same syntax, but for the age. Df clean age is equal to df clean age dot fill NA. Fill NA will impute the missing values based on the average age. Now, one thing that you must be sure about is this particular thing and this particular thing are two different things. When you add something like that in the commas, it basically means that this is a string and it doesn't have any significance meaning. Okay. But when you don't use these uh, like this, it will see the actual value that it contains and impute that particular thing. Okay. So just make sure whenever you are using something like that, you should not add uh, commas in here. But when we are adding unknown, we use commas because these are strings. Unknown doesn't have any defined logic behind it, and we are just going to see it as it is. Okay. And if we add commas here, then it will replace the missing values with average age in English, and it doesn't make any sense. Understood?
Yes.
Perfect. Now, beyond that, we are doing the same process, but for the salary. Again, the same syntax, we are calculating the average for the salary. Instead of age, we are going with the salary now. And after calculating the salary, we are imputing that salary with the help of fill and a function. Now, one thing that you need to make sure is that now we are working on a variable level or a column level, right? So we are not using the complete data in all of these lines of code. Here, when we are trying to rename the names, we give it in the brackets that we are working on the names only. And we want to fill NaN with unknown in the names only, okay? If you don't add that, it will fill in all the data set with unknown, and this will cause the problem. Okay, so whenever we are imputing missing values, we try to make sure that we work on the each column level, and it's a much better approach to impute the each column with its own nature. Yes.
Okay.
Now let's talk about the outliers. Okay. Outliers are the numbers in the data set that somehow don't make any sense and we need to treat them. Like in the age column, we have a age of 150, and this is not possible in today's era, and we should not have something like that, and we need to treat that, right? And we use df.describe here, right? And we can also use the df.describe after cleaning the data set. Like we clean the data set, now we have age in numbers and we want to use it. df.clean, describe. Now we are getting salary as well, we are getting age as well. Okay, because age was previously not in the format of in numeric format, that's why we are not getting that in the previous describe function. But since we treated it, now we have it here. And when we see this, we will identify the problem that there is the maximum age is somehow 150 and it should not be 150 and we need to treat that. Now, one of the best way to treat the outliers is to just treat the missing values. Okay, because 180, 150 doesn't make any sense. We don't know what the actual age will be. Now, if you want to go with the guess, that's totally fine. Like if you think that the age should be around 50 and someone added an extra one here and we should go with the 50. We can do that if we want to do. But a better approach would be to just treat them with missing values and impute them based on your own intuition, or you can just impute them with the mean. Okay. Now, since we are fixing that 100, again, we are calculating the average age. If you already calculated the average age here, you don't need to calculate it again. So just remove this line of code and it is not necessary. Okay. And now here we are using df.log function. Now log function is basically a function. Now in log function, what we do is we provide it with the data name. And after doing that, what we provide it with the condition for rows and with the condition for columns. Now here we need to define a function, the condition that what rows we are talking about and what columns we are talking about. Now since we are talking about the age column, that's why we are adding age after the comma. And before the comma, we need to add the condition for the rows. And condition for the rows is that age should be greater than 100. Okay. Now, whenever we see something like that in our data set, whenever Python sees something like that in our data set, that age is greater than 100, it will just equal it with the average age, the mean that we already calculated. Okay. If you want to go with your own intuition, like this is going to be 50 and someone mistakenly added 1, or it's going to be 15 and a 1 0 is additional, you can just come here and instead of average age, just give it 15 or 50 that you want to do. Got it?
Yes.
In the same manner, most of the salaries make sense, but somehow one salary is much higher than the other, and these should also be treated as outliers. Okay, and we can remove them with the same thing, that we can just use the mean function for the average salary, and based on the log command we can just update the value in the salary where it is higher than 500,000. Okay. Now these thresholds like 100 and 500,000, these thresholds, we don't have standard for them. Okay, it is based on our own knowledge about the data type and it's based on our own observations. Okay, if in the case of age, we know that age most of the time is greater than 100. Most of the time age doesn't go greater than 100 and we have less than that. Okay, in the in salary column, we can take this particular thing by just looking at the salary or by just looking at the summary table of salary, that this is the minimum salary and maximum salary is a way larger number. But if we talk about the 50%, it is around 57,000. If we talk about the 75%, it is about 76,000. So this, but anything beyond that point doesn't make any sense and we need to remove that, right? So still on the loose end, we just go with the 500,000. Now, this is something called outliers and how we identify them. We will get back to outliers when we are going in data visualization or exploratory data analysis. Whenever we work on exploratory data analysis, we are basically visualizing these. Now, in the sense of numbers, it is much easier to visualize the points that are far away from most of the data. And when we go to the exploratory data analysis section of the course, like where we visualize data and create multiple graphs, we will see that the outliers pop out and we have clear see that this need to be fixed. Now, one more thing that we also need to consider is while cleaning data is there should not be duplicate rows. A single row should not appear two times in the same data set. If we go to the first section, we have this line, John, 25, male, salary, department IT. And at the last, we again have the exact same line. Okay. Now, identifying duplicates is quite simple. It is just a single function. We just need to provide the name of the data and we just need to provide that duplicated function. Okay. It will just calculate the duplicated rows in the data, and if it use sum, it will just calculate the sum of them. And also, if you want to see the duplicate values in a single column, now like if we have a column like id is unique to each person and id should not be the same for two-person, right? You can just use the same function on a single column instead of whole data. If you're using on single column, we just need to add square brackets and give the name of column. Now everybody knows that id can't be duplicate, so we can also use that as well. Once you use that, we will get that we have one total rows, we have 9. Now to find the total rows, we use length function. Len is basically a length function that we can implement on any data set, and it will tells us about the total number of rows. And with the duplicated, we identified the duplicates. And also, if we want to see the duplicate rows, we can just see df clean dot duplicated and the sort values based on the ID. Since we have a single ID, if we don't do that, it will still works. When we use keep is equal to false, so basically we are not saving new data frame, we are just trying to see it. Now, since again we have a duplicated function to see the duplicate values, we have another function drop duplicates. It will just delete any one of them, so we don't have more than with that the same data should not appear more than one time in the data. We can also identify if we have some kind of weird age, like if data is related to employment or data is related to something like research, and there are some individual with age less than 18 or some individuals with age greater than 80, that somehow don't makes any sense and we want to treat them as well. For example, it's just a scenario, so if we have to work something like that in the future, so we do have an idea. Now, what we can do is we can use df.clean, same particular thing, and in df dot same data set name. In data set name, we are going to give it a condition to see our data, like or. This is or, and when we have this, it means and. So if age is less than 18 or age is greater than 80, we should save these entries in a new data frame with the name weird ages. Okay. And once we run these lines of code, it will just go through the data. If we have age less than 18 or age less than 80, it will subset the data for them and saved it in the weird edges. And if we want to see the length of weird edges, we can just use length weird edges. Okay. And once we run this, it will show us that age is outside normal range. So basically we print this text on our own and we added extra length with it. Okay. Now there are no entries with that meet such a condition. So that's why it's giving us 0. We have with one entry with 150, but we treated it with the mean value and it now contains value like 48. Okay. Now let's talk about something like salary. If we want to see something, the salaries where salary is less than 20K or greater than 200K, we can also see that with the same condition. Just we need to change age with the salary and the condition with the actual salary that we want to see. Now, this is simple condition, like if this length of salary is greater than 0, it should show this data. Otherwise, it should say all salaries looks good. Okay, since we have a problem in our salaries, that's why it's showing this particular data. Do you have any question?
No.
Okay. The last thing that we need to treat is the multiple categories that should not be there. Male, female, and FM. Instead of all these, we just have two clean categories with female and male. Okay. Now, we already studied the replace function. This is going to be the simple. We are talking about the gender. And in the gender column, we are just replacing F with females, M with males. So we are trying to with two standard names, female and male. So we will replace this FM with the same. We will replace this female with the same female as well. Okay. And once we run these lines of code, the F will be replaced with the female. With this line of code, M will be replaced with the male. And with these lines of code, a female with the small f will be converted into female with the capital M. F. Got it?
Yes.
So now we replace the missing values where we have problems like F, M, female with small f, and we also replace the HR with the capital one, IT with the capital one, and finance also with the capital F. Okay. And by doing so, what we are going to see is we almost removed all the inconsistencies. Like in gender, now we have clean male and female, right? And in IT, in department, we also have clean IT, HR. I mean, we have perfect categories. We don't have any category replicated with different names or different convention. Got it?
Yes.
Okay, so these are different types of data cleaning process that we can do.